Hello people and welcome to another video of Programmer's Corner. In this video we'll take a look at how to implement Radix Sort on a set of given whole numbers, in this case integers. So to begin with, we have this array of 10 elements where each cell points to a linked list, and we have to use this data structure to sort this given set of integers. So initially what it does is we keep track of which is the largest number. We store the largest number and the length of that number, that is how many numbers long is the largest number. So in this case the largest number is 20 and it's 2 numbers long, so its length is 2. But since we are also using negative numbers, we'll make that length as +1, so it's 2 + 1, so we'll consider the length as 3. So the length is, in this case, the length is used to keep track of which units place we are going to shift on each number. So let me execute this and show you how it works. So we have the first number as -1. So we take the -1 number and now start with its units place. So its units place is 1, so I go to index 1 and I insert -1 in there. I'm taking a number, I'm looking at the number at its units place. I take number 20 and its units place is 0, so I go to index 0 and I insert the number there. Now I take number 5, its units place is 5, I go to 5 and I insert the number there. -7, its units place is 7, I insert -7 in there. It's -12, the units place is 2, so I insert -12 there. It's 12, it's again units place is 2, so I insert 12 here. Now this insertion is done in ascending order, so the first number will be from the smallest to the largest. 15 goes at index 5 because its units number is 5. The number at the units place is 5. -14, its units number is 4, so it goes at index 4. And 11, its units number is 1, so it goes at index 1. So this is our first iteration. Now the second iteration is always going to be over this array. So we start at 0 and we are going to look at the 10th place of a number that we select. So the 10th place value of 20 is 2 and it's not in the proper index. So we remove this number from here and we put it at index 2. Since there is nothing here to look forward to, we go to the next index and we see -1's 10th place value is 0. So I take -1 from here and I put it at index 0. 11's 10th place value is 1. Well, it's perfectly fine. So I go to the next index, index 2. -12's 10th place value is 1. So I take 12 from here and I insert it in 1. Since this is ascending, a 12 comes before 11. -12 comes before 11. The same thing with this 12. And it goes after 11 since it's greater than 11. 20 we have previously inserted from, we took it from 0, which was here, we brought it here because of the same value, stays here since it's in the proper place. We are looking at the 10th place of a value that we select. 3 has nothing. 4 has -14. Its unit place value is 1. So its 10th place value is 1. So we take 14 from here and now we insert this in a proper ascending order. Now there is nothing for 4. We go to index 5. The 10th place value is 0. So I take 5 and I put it after 1. -1. 15th 10th place value is 1, so I put it after 12. and we have the negative 7 here. Its 10th place value is 0, so I put it before 1. So now if you look at only the positive numbers, now this is the iteration is done since there are no more values. If you only look at the positive numbers, they are perfectly sorted. So you have 5 in this place, 11, 12, 15 and 20. But since we have negative numbers, these two numbers should be here and they should not be in this position. They should be at 0 index and not at the first index. So how do you sort it? So now we look at the 100th position of the 100th place of a given number. So the 100th place of these three numbers is all 0, so we do not change anything. We go to index 1 and we take the 100th position of 100th place of negative 14, and we see that negative 14 and negative 12 both should come above negative 7 since its 100th position is 0, place number is 0. So I take these two numbers and I shift it above this three numbers. I place them here. And 11, 12 and 15 also have its 100 number as 100 place number as 0, so I take these three and I shift it below this 5 since the insertion is in ascending order. There is nothing here, and then we go to 2 and then we see that the 100 value of 20 is 0 again, so I put 0 after 15. And since we have completed all the three digits, we have iterated through all the three digits, the units place, the 10th place and the 100th place, we have basically completed our sorting. And now if you look at the 0th index, you see that we have a list of numbers that are list of these numbers that are in sorted order. So that's how the insertion dot works. If it only was a set of natural numbers with no negative numbers there, we could have easily stopped at the previous iteration because the list, as you could have seen, was already sorted. We just had to go through each of the index again and print the list as it was. So now we'll take a look at how to actually implement this algorithm in Java. So here we have created the table from 0 to 9 as given in this data structure. So we have a table from 0 to 9 that we have created, an array of 1D array of 0 to 9 with each cell pointing to a linked list, and we have created a data and we have randomly generated numbers from negative 20 to 20, both sides included. And here we have basically taken into account the maximum length of the number. So if it's if the number is less than 0, then we basically if we ignore the first negative sign, we convert that number into a string, we ignore the first negative sign, and then we take the length of that number. Else we just take the length of that number, and then we pass the data, the array, the table and the max length into a radix sort function, which returns void as a return value. It basically returns void. So here the coward L basically is the position at which we are at on the given number. So is it the units place, the 10th place or the 100th place, and so on and so forth. So the initial iteration, we first fill up this array. We first fill up this linked list, and how we do it is that if the number is less than 0, we convert that number into a string, we subtract 2 from them, we subtract the length 2 from them. So if it's -1, it's going to be -1, its length going to be 2, and so its length now is going to be 0. So we see if the covert length is the same as or is less than the total length. In this case the covert length is 0, so we are pointing at the units place. then we go in and we say that the covered length minus the total length, that is 0 minus 0, in this case is going to be 0, plus 1, which then comes to the first character. So if the number is minus 1, its first character, you convert that to string, its first character is 1, it's not 0. So it's not minus, because its 0's character is minus, its first character is 1. So we take the 1 and then we say that we convert that 1 into a integer again, and then we pass that as a index value to array R, which is of type Radix Sort, and we pass it in and we get the list, which is, we get the list from here, the list head, which is this, we get the list head, and then we do the insert data. So the insert data function is in the list class, where it gets the dummy node and then it sees if the dummy node's next is null, then I just insert the data, else I have the previous node and the next node, and then until I hit the end, or until I have found where I have to do the insertion, I keep on going. So here, if the next node's data is less than or equal to the data that I am trying to insert, then I go to the next. If the next node's data is greater than this current node data, then I just break and I know that this is the place I have to insert. That's the place I have to insert. So I said the previous node's next is the new node, and the new node's next is the next node. So that's the insertion. So I go on inserting into the table, into this table, and that's my first iteration. Now after that iteration is done, if it's so before that iteration is done, if it's a positive number, I just go and directly insert it according to its given position. So in this case, if it's 7, it's at index 0, since there is no negative in there. If it's 14, then it goes to 1, and this is 0, so it goes to 1 minus 0, that is 1. So it's 14, then it's at index 4 or index 1. So index 1 in this case will be 4, or number 14 if you convert that to string. So, and then this is the same as the previous, we get the list head and then we see, and then we do the insertion in that. Else, if it's less than, if the total length, if the covered length, let's say if the total length, in this case if the length of the number is 2 and the covered length is 3, that means we are at the 100th position or the 100th place of that number, then we know that it's automatically going to be 0, so we just insert that number into the 0th index of R, the 0th index list. After the first iteration, we go to the covered list, we increment the covered list. Now we going to look at the 10th place. Now we run this iteration till we have the covered length less than and equal to the max length, because since we are also using the negative numbers, we also have to take into consideration the situation we faced before, where even though the positive numbers were perfectly in order, the negative numbers were not properly sorted. So now we get the first node, and then we see if the first node is not equal to null, we iterate through the R list. We basically iterate through this, as I stated before. We no longer look at this. We take the first index and we see if there is a list. We take the first index and now we see if there is a list. If there is a list, then I get the first data, then I get the data of the first node in the list. Now I see if the data is less than 0. If the data is less than 0, I do the same exact thing, but here we also have to delete from the previous one. So let's say I took the data, everything's perfect, so we are perfectly in range of the given number, or let's say it's negative 14, so we are perfectly in, since this is 1 and this is also 1. We are perfectly in range, so this is at index 1, so this now we are at index character s is 1, but this one is at index 0, I is 0 and this is 1, so we are not in the proper set here, since that number should be now in here and not here. So or negative 10, that would be a perfect example, negative 10, because 0 was at this, and the second the 10th place is 1, so the unit place was 0, 10th place is 1, so now negative 10 should come here. So what it does is it takes the number and it inserts it deletes the number from out of 0, it deletes the number from here and it inserts it into here. So let's see how the deletion works. So for deletion, it takes the number integer that it wants to delete and it returns the next node of the node that we are going to delete. So we come here, we get a dummy node, we see if the list is empty, then we just return null, else we have the track pointer to the previous and to the next, the deleting node's next one, and because now we have to connect the previous one to the deleting node's next one, we have to also reconnect the pointers. So until we say that the next node is not equal to null, we see that if the next node's data is equal to the given node, then we set the temp node delete to the next node, and the previous node's next is set to the next node's next, and the temp node's delete data is set to temp's node set next is going to be null, and the return is the previous node's next node, which is now this next node. So in this case, if this is null, this is going to return null because there is nothing else to see, else it's going to return the next node. If it's not the data that we are finding, then that we have found yet, then we go to the previous node's next node, and then we go on assigning variables. We go on moving to the end of the list, and then if we didn't find anything, we just break and return null, which this case doesn't mostly happen because the data exists. So this one returns the pointer, this one then points to the next of the deleting node, and then we insert the data into the node that we want the data to be, or in the index that we want the data to be. So if we are deleting negative 10, then the negative 10 will go off from here, and then it's gonna get entered in here. So its negative 10 is gonna get added in here and deleted from here. But what if the negative 10? But what if we are in the proper thing? We want to delete some, let's say called 11. So in this case, 11 was already in here, but the 10th place matches with the index that it's currently in. So in that case, we just go to the next number in that list that we want to delete. And what if the number in this case is already been covered, the length of the number has already been covered, so the number is probably 3 digits long, and we are going to the 4th digit, then we are looking at the 4th digit of the number and is 0, then we do the exact same thing. If it's not in the 0th, if I is not in the 0th place, then I remove the number from there and put it in the 0th list, else if it's already in the 0th list, I just go to the next number. Now this is if the number is negative. What if the number is positive? So in that case, it's perfectly simple. You just take the number that's already in there, you take the total length that we have, and then the total length that we have covered to get the exact value of the exact number exact index that we want to put that number in. We again see if the number is in the index that we want to put it in. If the number is not, then we have to remove and then insert, else we just skip that and go to the next number. The same thing with the 0th index. If the number is not in the 0th index, we just remove it and we put it in the 0th index, or we just go to the next one. And at the end of the for loop, at the end of this while loop, we go on until we do not reach the end of the list, or we have not completely deleted the list. we do the same thing for the for loop. We iterate through the entire list, we iterate through the entire array, we iterate through the entire array, and then we increment the position to the next place. So now we have done with the tens place, now we go to the units, hundreds place, then the thousands place, depending on the size of the number, and so on and so forth, until you come all the way to the end, and until you're done executing this, until you're done executing the entire numbers placement positions. So let's execute this and see what it gives. So these are this is the list that we have created: negative 16, 15, 10, negative 6, 0, 18, 18, negative 8, negative 15, and so on and so forth. And if you look at that, it is perfectly in order of this. So rather than doing this way, let's try to print this after each loop. So after each loop, let's try to print the R. So we'll see. So this is not I, this has to be something else. Let's make it P. A little better. So now we have this, and now we have this. So now we basically can see how the system works, how things work in here. So if I run this again, it's gonna give me these numbers. So I can remove the one at the end. I don't need this one here because it's already printing it twice. It's printing the output and the result twice. So now if I run this again, it's gonna give me this. So the first iteration we have, okay, I need to print the first iteration again because I'm only taking the first and the second and the next iteration. I'm not taking this iteration before that. I'm not taking what happens if it's done before. So as you can see, this is the iteration that we are entering. So we have negative 10, 10 and 10 in the first one. Then we have negative 11, negative 1, 11, 11 in this one. Now here we are only looking at the units place instead of looking at any other places. So in this case, these are the perfect, these are exactly in the perfect places. Now we look at the tens place, and we have perfectly inserted all the numbers where they are needed to be. All the tens place of these numbers are 0, the tens place of these number is 1. And now if you look at the hundreds place, if you look at the positive numbers here, they are perfectly in order, they are perfectly in sorted order. But if you look at the negative numbers, they are not. So if we look at the hundreds place, and now we can see all the numbers are in perfectly sorted form. If you run this again with a set of different numbers, you probably can see how these things work. So here again, we'll take a look at the unit number. Here we take a look at the tens number, and here we take a look at the hundreds number. So as you can see, this is an example of a Radix sort, where we generate 20 random numbers, and then we sort them using iterations, where we take the largest number, we see how many numbers it forms with, and then we iterate that many times. If it's negative, we iterate one more so that we get a proper sorted ordered number. But for a non-negative numbers, if you are only considering natural numbers from 0 onwards, you can just stop at this iteration, because if you look at this value here 0669, and from here you have 12, 17 and 20. It's perfectly in ordered form. It's perfectly in sorted form. So that was Radix Sort using linked list. For the next video, we'll look at Radix Sort using binary trees, most likely height balance trees, because in this case, if you look at if we have like millions of numbers, the list is in this case is going to be too large, and the complexity on each index is O of k, where k varies for each list. But instead we can reduce that thing down to O of log k by using height balance trees, where we actually only have to go down a binary tree, a balanced binary tree. So if you like this video, please comment, share and subscribe, and see you guys in the next video. Thank you for watching.